Vectors at angles. So before we even start with directions, we need to know the basics. We will always assume that the top of the page is going to be our north, the bottom of the page is going to be the south, the left will be the west, and the right of the east. To remember this, you can remember the saying, never eat slimy worms, so never eat slimy worms. I always remember top and bottom being north and south, and then it has to spell we. But any way you remember, it'll be fine. There's actually 3 different ways to measure angles. I'm going to show you one of the 3 methods. So we're going to need to do this a protractor and a ruler. So first thing you need to do is look at the scale. So I got a couple examples here. It says measure the following, and our scale is 1 centimeter is equal to 1 meter. So that means for every centimeter that we measure, that equals 1 meter. So when you put your ruler down, you're going to measure right to the tip of the arrow. And when I do that, I'm measuring about, and I line this up, 3.4. 0.5 is right here, so 3.4 centimeters. So that would mean 3.4 meters. Now our direction is always in square brackets. And there's 2 ways to do this. You always put your protractor on north. So if I line this up with the little crosshairs of that I'm drawn here, if my 0 is on the north, I'm measuring 42 degrees towards this way, which is east. So I'm going to write it exactly like that. It's north, and then I went 42 degrees, because I can see it through my protractor, towards the east. So I write that down exactly like that. So it's north, 42 degrees towards the east. The other way I could have done this is put my protractor for my 0 on the east. So if I do that, I have my 0's on my east, so I write that down first. So I go east, and it looks like I'm moving up 48 degrees towards the north. So 48 degrees towards the north. Like I said, both these are measuring the exact same thing. So it doesn't matter which way you put your protractor. Now, if you were to put your protractor down like this, that would be completely wrong, because your line here, your angle, needs to be within the 90. Another one that would be wrong is something like this. That also would be wrong. So let's try another one. So the one beside here, first thing we want to do is measure our line. And we're always going to measure from the tip of the arrow back. And I'm measuring, looks like maybe 2.6. So I'm going to write down 2.6 meters. Now my direction is going to be in square brackets, and there's 2 ways I could actually put my protractor down. This would be wrong because my angle is over here and not inside my protractor. So if I put my protractor, I'll line it up with the crosshairs right there. I'm looking at these crosshairs. I'm measuring about, that's 20. So maybe 18 degrees. So my 0 is on west, and I'm moving 18 degrees down. So it's going to be west, 18 degrees towards the south. So down is south. There was another way I could have put my protractor. I could put my protractor, once I line it all up, like this, where my 0 is on south, and I'm moving to about 72 degrees towards the west. So I could have written it as south, 72 degrees west. And we just keep doing that. This example is kind of interesting. So when I put my ruler down and I measure to the tip of the arrow, that looks like about 2.5 meters. And there's no angle this time. This time I'm pointing directly south, so all I would do is write down south. And that's how you measure angles. Next, we're going to draw them. In order to draw a vector, first thing we need to do is come up with a scale. So if what I'm trying to draw is 35 meters, obviously I'm not going to draw 35 meters, but we could come up with a scale. Try to get things that are simple, like factors of 1 to 1, like we had in the example here, 1 centimeter equals 1 meter, or 1 to 10, 1 to 100, but 5 is also an easy number. So let's say I say 1 centimeter is equal to 5 meters. Well, to get to 35, I'm going to have to draw 7 centimeters because 7 times 5 is 35. All right, so the next thing we need to do is draw a starting point. I usually just mark this with an X. I know I'm going to be going north, so I want to start a little bit lower. I'm going to start near the bottom of my page. So I just put a little X down. And then you simply, because it's straight north, I'm going to take my ruler and draw a line that's exactly 7 centimeters straight up. So the line itself is going to be exactly 7 centimeters. And at the tip of the line, I'm just going to draw my little arrowhead down. So when I measure this, I'm measuring 7 centimeters, and I know 1 centimeter is equal to 5 meters. So 7 times 5 is 35, and it's pointing in the direction north because that's my direction. We're going to try a slightly more difficult one now. So I have 100 meters per second north, 20 degrees east. First thing you need is your scale. You always start with your scale. So I'm going to say 1 centimeter is equal to, let's say 10 meters per second. Because if it's 100, I just have to draw a line that's 10 centimeters long. I need my starting point. Well, I'm going north and to the east, so I need to start down here someplace. And for my little starting point, I'm just going to draw little crosshairs down. Let's just move this over a little bit. This way I could just line up my protractor nice and easy. Okay, my direction. My direction is north, 20 degrees towards the east. So when I put my protractor down on my little crosshairs, okay, I want my 0 on the north, and I'm going to move 20 degrees towards the east. So you find 20 and you put a little tick. There's my little tick. And I'm going to line up this crosshair with that tick. And my line is going to be exactly 10 centimeters. So I put my ruler down and I line the two up, and I go over the question a little bit. Let me just move this down. Needed a bigger page. And you draw to 10 exactly. So once you get to 10, you stop. And you just draw your little arrowheads back. So what I have is, this is north 20 degrees. That's 20 degrees towards the east. 20 degrees towards the east. Here's our last example. So we're going to draw 40 kilometers west, 50 degrees towards the south. First thing we need is a scale. Well, it's 40. So if I go 1 centimeter is equal to 10 kilometers, that would be fairly easy. I would just have to draw a line that's 4 centimeters long. Next, I need my starting point. This time I'm going west and then down. So I need to start a little bit higher. So I'm just going to put my starting point with little crosshairs. So I know where's north, south, east, west. I'm going to line up my protractor. My 0 needs to be on the west. So I put my protractor down. My 0's on the west, and I want to put a little tick at 50. Here's 50. You put a little tick right there. And now all I have to do is line it up and draw my line. My line's going to be 4 centimeters. So I have to line this up. So you go right from 4, you draw a line that's exactly 4 centimeters, and you just draw little arrowheads going back. And I'm done. So far we've been practicing drawing vectors and measuring what vectors are. Next, I want to add vectors. So the steps are actually very, very simple. So steps for adding vectors. First thing, you choose a scale, which we did before. Then you want to mark your starting point with an X. Sometimes I mark it with little crosshairs because it's easy to set up my protractor. We're going to draw our first vector with an arrow on the end pointing in the direction of that vector. So that's what we've done so far. We've been practicing that so far. Here's the new part. If you have more than one to draw, so wherever that one finished, that's going to be our starting point for our next one. And if there's only 2, then you're done. So wherever the first one started, your X, and your last one ended, that's called our resultant. And we're going to draw that with a dotted line. And the last thing you do is you just simply measure your resultant to find the displacement. So next we're going to try an example showing you exactly how to do this. Here's our example. It says Brandon walks 30 meters north in 25 seconds. then 40 meters west in 37 seconds, and finally 53 meters south 30 degrees west in 1 minute. And we're going to look for a bunch of different things. The first is his total distance, his displacement. We're looking for the average speed and the average velocity. Before we even begin, we should start by writing down all our given information. So the first thing I know is this first displacement here. So I know my first displacement is 30 meters north. So 30 meters north. And that happens in 25 seconds. So I'm going to call it T1 because it's the first thing that we do is 25 seconds. My second displacement is this one here. It's 40 meters west. So I'm going to call it D2 because it's the second one. And that is 40 meters west. And T2, that time was 37 seconds. Finally, my third displacement, I'm going to call it D3 because it's the third one, is 53 meters south 30 degrees west, and that time is 1 minute. So T3 is 1 minute. Before I even begin, there's a problem here. I have seconds and minutes. I need to change this to seconds, and I know there's 60 seconds in 1 minute, so that's nice and easy. So first question, A, says, what is the total distance covered? Well, distance, the total distance, you just add all the distances together. So it's going to be D1 plus D2 plus D3. Write them in. So we have 30 plus 40 plus 53. And that works out to be 123 meters. All right. In B part, it says, what is his displacement? So what we're going to do now, because the directions aren't just as simple as north-south, where you can use a minus sign, or west-east, where you can just switch one to negative. When they're pointing in physically different ways, like one's going north, one's going west, one's going off on an angle, you have to draw it to scale. So let's draw these vectors. First thing we need is a scale. And if I have 30, 40, 53, I'm going to pick 1 centimeter is equal to 10 meters. 10 is a really easy number because that would just be 3. That one would be 4. That one would be 5.3. Our next thing we need is a starting point. So all you have to do is put an X someplace. So let's say there's my X. My first one was 30 meters north. So I'm going to draw a line exactly 3 centimeters up. So 3 centimeters. And I draw my little arrow coming back from that. My next one is 40 meters west. So I put my ruler down and I draw a line exactly 4 centimeters going towards the west. Right there. So this one went from here to here. Where this ended is the start of my new vector. Goes here. But there's a third one. So where the second one ends is where my new one begins. And it is south 30 degrees towards the west. So I'm going to put my 0 on south. And wherever I see the 30, I put a little tick. There's my little tick. And I want to make this one 5.3 centimeters. So 5.3 is about there. So I draw my line exactly 5.3. At the end of the line, I draw my little arrowhead. Okay, so the displacement is where did I start, where did I finish? So now I'm going to draw a dotted line joining the two. And then I'm going to measure it. So my dotted line is my end result. We call it the resultant. You always draw it as a dotted line so you don't get it confused with the other lines. And when I measure this, it's about 6.8. So that would be 68 meters. And I need a direction. So I'm going to take my protractor and I'm going to put my 0 on my west. I could put it on south too. And when I measure that, I'm getting about 14 degrees. So it's west 14 degrees. Yeah, I'd say about 14. West 14 degrees towards the south. So west 14 degrees south. And that's my total displacement. So the only way to get displacement when you have completely different directions, like a north, a west, an east, a south, is by drawing it to scale like this. part C is asking us for the average speed. Well, we know V average is equal to the total distance divided by the total time. I know what the total distance is. I did that way up here. So the total distance was 123 meters. What I haven't calculated yet is the total time. So I want to do that. I'm just going to do it off to the side. So my time total is equal to my time 1 plus my time 2 plus my time 3. My first time was 25 seconds. My second one was 37 seconds. My last one was 60 seconds. When I add those three numbers together, I end up with 122 seconds. So now we can actually solve the question. So my total distance was 123 meters divided by my total time, which was 122 seconds. And that gives me basically 1 meter per second. To find the average velocity is very, very similar. The formula is almost identical. So it's my velocity average is equal to my displacement divided by my time. So the difference between speed and velocity is one uses the distance, the other one uses the displacement. And I actually calculated the displacement already as well. So my displacement is 68. My total time was 122. And when I put that into my calculator, I get 0.55 meters per second. And I need a direction. And the direction hasn't changed. It's still west, 14 south. So speed is distance divided by time, and velocity is displacement divided by time.